Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm your host, Victor, and with me, as always, is the brilliant Sheila. Today, we're diving into Chapter 3 of our journey through operating systems, all about processes. Sheila, want to give our listeners a quick overview of what we'll be covering in this chapter?
Absolutely, Victor. Chapter 3 is all about processes, which are fundamental to understanding how operating systems work. We'll be exploring the process concept, scheduling, operations on processes, and inter-process communication. Today, we're starting with Section 3.1, the process concept. This is a crucial foundation for everything else we'll discuss in this chapter.
That's right, Sheila. And for our listeners who are preparing for interviews or just want to understand operating systems better, this is a topic you'll definitely want to pay attention to. So, let's start with the basics. Sheila, what exactly is a process?
Great question, Victor. A process is essentially a program in execution. But it's important to understand that a process is more than just a program. Think of it like this. A program is like a recipe in a cookbook, while a process is the actual act of cooking that recipe.
That's a great analogy, Sheila. So a program is static. It's just instructions and data sitting on the disk. But a process is dynamic. It's the program in action, with the CPU executing instructions and accessing memory.
Exactly. And just like how multiple people can cook the same recipe at the same time, multiple processes can be created from the same program. Each process has its own unique execution context.
That's a key point for our listeners to remember. Now, Sheila, processes don't just exist in one state, right? Can you tell us about the different states a process can be in?
Absolutely, Victor. Processes typically have three main states: running, ready, and waiting. When a process is running, it's actively being executed by the CPU. When it's ready, it's prepared to run but waiting for the CPU to be available. And when it's waiting, it's unable to run until some external event occurs, like completing an I/O operation.
I love how this relates to real life. It's like being at work. You're either actively working on a task, running, ready to start but waiting for your boss to give you the go-ahead, ready, or waiting for someone else to finish their part before you can continue, waiting.
That's a great way to think about it, Victor. And just like at work, processes transition between these states. The operating system manages these transitions, which is crucial for efficient multitasking.
Speaking of managing processes, the operating system needs to keep track of all this information about each process, right? How does it do that?
That's where the process control block, or PCB, comes in. Think of the PCB as a process's ID card or passport. It contains all the information the operating system needs to manage the process.
Fascinating. What kind of information does the PCB contain?
The PCB typically includes the process state, program counter, CPU registers, CPU scheduling information, memory management information, accounting information, and I/O status information. It's a comprehensive snapshot of everything the OS needs to know about the process.
Wow, that's a lot of information. It's like each process has its own detailed dossier. Now, Sheila, we've mentioned that the operating system can switch between processes. How does that work?
That's called a context switch, Victor. When the CPU switches from one process to another, the operating system needs to save the state of the old process and load the saved state of the new process. This state is, of course, stored in the PCB.
That sounds like it could be time-consuming, is it?
It can be, Victor. Context switches do have some overhead, which is why operating systems try to balance the need for multitasking with the cost of frequent context switches. It's a classic trade-off in operating system design.
This is all fascinating stuff, Sheila. To recap for our listeners, a process is a program in execution, not just the static program code. Processes can be in different states like running, ready, or waiting. The operating system keeps track of all the information about a process in its process control block, or PCB. And when the OS switches between processes, it performs a context switch, saving and loading process states.
That's a great summary, Victor. And remember, listeners, understanding these concepts is crucial for grasping how operating systems manage multiple tasks and provide the illusion of simultaneous execution on a single CPU.
Absolutely, Sheila. Well, that's all we have time for in today's episode. Thanks for tuning in to Operating Systems Crashcast. In our next episode, we'll be diving deeper into process scheduling, so don't miss it. Until then, keep those processes running smoothly.
Goodbye, everyone, and happy computing!